Dear colleagues, welcome. My name is Nicolas. I am Osstem course director from Switzerland. Today I would like to present you Osstem 1-2 taper kit and Hiossen S3 ISQ Monitor. The content of this short lecture is: what is the concept of 1-2 taper kit? What are the components? How is the drilling protocol? And I would like to give you a short demonstration how to drill and how to use ISQ Monitor. So let's start with the concept. 1-2 stands for reduced number of drilling. In soft bone you only use one taper drill. In normal bone you use 2 taper drills. As well in hard bone you use 2 taper drills. But the concept also fits for different implant diameters from 3/0 up to 5/0 millimeters. And this is quite amazing. When we look back at the traditional taper kit, and by example we would like to place a 5/0 implant, then normally we go through all the drills from lance drill 222, 3.5 and so on up to 5 millimeters. So how it is possible to do drilling with reduced number of drills? When we take a look here, again we would like to place a 5/0 diameter implant in normal bone. We use only 2 taper drills and first a guide drill. And when we do drilling, of course we have to enlarge. We have at the same time to be precise and adequate. We don't want any wobbling, heating or wrong pathway. So what is the secret of the 1-2 taper kit? It is the shape of the drills. They are so-called step drill. When you take a close look, you can see here the steps. And what are these doing? They do a shape like a stairway in the bone. And when you use a drill, the previous drill already made the shape in the bone, and the following drill follows exactly this shape. So this is the concept. It has a lot of advantages. It is more efficient. You need less chair time. This is maybe not so important if you place one implant. But when you place multiple implants, like in an all-on-6 case, it makes a big difference. It's also very convenient to use. It's easy. It's safe, it's precise, and it generates less heat. It's also more economical because you use less drills. And a big advantage, the drilling concept is exactly the same as in the fully guided kit, so-called the one guide kit. The drills look a little bit different, but the drilling concept is exactly the same. Okay, let's take a look at the drills. There are many drills, but the kit is not as complicated as it may look on the first look. We can make 3 main compartments. There are drills for real bone drilling, then of course some fixture drivers and also prosthetic parts. When I compare the 1-2 taper kit to other surgical kits from other brands, in my opinion there are some really nice features that really stand out. Many of the compartments have a real clever design, and I would like to present you this shortly here. So here I have my 1-2 taper kit. It's a steel bow, a torque wrench, a depth gauge. And here are my main compartment. Here are the taper drills, guide drills and prosthetic part. Now by example, when I take a look at the first drill, it's a so-called the guide drill. You can see it has some side cuts. So it's kind of a Lindemann drill. It's a very efficient drill and I really like to use it, also especially when I place implant in the front area. By example, when you place an implant in a position of an incisor, often the first step you drill, you have a direction like this and then you do kind of a rotation. So you start like this and then you rotate your drill. When you don't have these side cuts, there's a risk that your drill is slipping and you get a wrong pathway. Then another nice feature is the drill extension. You can see here it's very narrow. The advantage is a better water cooling and a better view on the main drill. Here are two drills, two line of drills. You use them mainly when you place narrow implant like 3.0 or maybe 3.5 in very soft bone. You can see the color is a little bit different and this is why these drills are coated. It's a special coating that makes the drill standing longer. Let's come to the main compartments. These are the taper drills. When I pick one out, maybe this one, you can see they are color coded, but they have also very nice laser marks. You can read the diameter and the length of the drill. This is very important. Always when taking a drill, you have to check having the right drill. There may occur an error during the sterilization process. You can also see that there is a line on the drill and the drill stopper. So the line is corresponding to the length that is written here. In this case, by example, 11.5. And the distance between the black line and the stopper is 1 millimeter. That means when you drill up to the stopper, you drill 1 millimeter deeper. And this is of course by purpose, because you should always place your implant a little bit below the bone crest. Maybe sometimes even a little bit deeper than 1 millimeter. Then let's come to some nice features of the prosthetic parts. What I really like is the screwdriver. It sounds simple, but not all the screwdrivers are the same. From all different implant brands, this is the screwdriver I like the most. Why? They're different lengths. It's turning, it's convenient to use. The grooves are only in one direction, so it's easy to clean. But the main advantage is that the end is conical. So that means when I grab, like by example, a healing abutment, like here, due to the conical connection, it's very safe. There's not a risk that my healing abutment is falling down in the mouth and patient maybe can swallow this. So really nice features. Also the torque wrench. There are different designs of torque wrench, but I think the design with the bar is the best one. It's the most precise and it is nicely made. You can sterilize like this. You don't need to disconnect. It's hermetically sealed. Okay, let's go back to our presentation. What is the drilling sequence? As we already mentioned, in soft bone you need only one taper drill, and let's say again we place a 5.0 millimeter diameter implant. We place in soft bone is our last drill is a little bit smaller than the implant. In normal bone we use 2 taper drills, and the last taper drill is the same diameter like the implant. In hard bone, we again use 2 taper drills, and the last drill is 1 diameter bigger than the diameter of our implant. So it's a very logical protocol. Okay, when we start drilling, we first use the side cut drill. The side cut drill is actually a Lindemann drill. It's located here. It has no stopper, but you can attach a special stopper if you like. You use it like this. In this example, you're going down to 10 millimeters, which corresponds to the black line, the dark black line, the big black line on the lower part. Then you can, if you like, you can check the path of your drilling with the so-called parallel pin. These are really small pieces. They easily can fall in the mouth, so they have a small hole, is located here, the middle of this part, and you can attach a tooth floss to secure this part. After using the side cut drill, you already go to the taper drills. Let's see, in this example, for the 5.0 implant, we use the 3.5 taper drill on the length we wish, 10 millimeters, and we go down to the stopper. So that means our drilling is in fact 11 millimeters, 1 millimeter longer than the drill is marked. Again, we can check parallelism or the path of our drilling with another kind of parallel pin. Then we go to the second taper drill, and this normal bone hardness. In this case, we use the 5.0 taper drill. And again, we go down up to the bone stopper. Then our drilling is finished and we can place the implant. You can buy implants with mount or without mount. When you place implant with mount, normally, or in most cases, you can connect the mount driver to your contrangle and you can put in the implant. You should not use too much speed and also not too much torque. How deep you should place the implant? Ideal depth is a distance from implant shoulder to the free gingival margin of about 4 millimeters. And how you can measure this? There are different ways. When you place your implant to final position with the mount, your mount has here some horizontal grooves. First one is at 2 millimeters and the big one is at 4 millimeters. So this mark helps placing the implant on the correct depth. But often we do not place the implant in final position with the mount. What we normally do is we place the implant but not the final position. Maybe we leave some millimeters out of the bone, like 3 millimeters, or until we have a good primary stability of maybe 30 Newton centimeters. Then we can remove the mount with the screwdriver and we can drill in the fixture with the fixture driver, the driver that goes directly into the implant, normally connected to the torque wrench. Another option is you can buy your fixture without mount. Normally, when you use fully guided surgery, the one guide kit, you use a fixture without mount. So without mount, you use the no mount driver, again in the contrangle. You remove this and then you can place your implant to the desired depth, normally by hand, by torque wrench and the so-called fixture driver. And again, on the fixture driver, you can see here some marks, and your distance between implant shoulder and free gingival margin should be 4 mm, and this corresponds between the second two last lines. Okay, when you having placed the fixture, you can drill in the cover screw, or when you have easy case, sufficient torque, immediate stability, then you can also place a healing abutment. Okay, let's summarize the drilling protocol. In all different bone hardness, I always use first the side cut drill. When I have soft bone, I use the 4.5 diameter drill. That means 1 diameter smaller than the fixture to be placed, and I can already place the implant. So I use one step, one taper drill. In normal bone quality, I use again the 3.5, and then I go to the same diameter taper drill like the fixture to be placed, in this case the 5.0. In hard bone, I use again the 3.5, but then I go 1 diameter larger than the desired implant diameter, in this case 5.5. So this is the very logical drilling protocol. As the drilling protocol is reduced, don't forget to check your path. There are different ways like parallel drill or deft gauge to always check your inclination of the implant. To be sure, it's always a good idea to take an X-ray during surgery. Some words about Hiossen S3 ISQ Monitor. ISQ stands for Implant Stability Quotient. It's a number and it's measuring the stability of the fixture. The higher the number, the higher the stability. And you should achieve a stability ISQ maybe more than 60. When you have even higher, you can do a one-stage surgery or even an immediate loading. But measuring the ISQ after implant placement is also a great tool for improving your learning curve. You faster develop a feeling for the bone hardness. Okay, now I would like to give you a short demonstration how to use 1-2 taper kit and ISQ monitor. Okay, here I have my 1-2 taper kit, and I have a bone block model for soft bone, normal bone hardness and for hard bone. Okay, let's start drilling. The implant I like to place is a 5.0 by 10 mm TS3 implant. Okay, so first I use my side cut drill, and the 10 mm is the length below the big dark line. Okay, so I start my drilling in soft bone, then I go normal bone and hard bone, and pay attention to the sound and also the force I use. So I start my drilling up to 10 mm. So this was soft bone, very fast, very easy drilling. Let's see the difference in the hard bone. You can see I need much more time, and I do also some pumping action. And here, normal bone, of course, it is something in between. Okay, this was first drilling. Then I can check what drill I have to use next. Okay, the implant I would like to place is a 5/0 fixture. I already used the guide drill, and now in soft bone I go 1 diameter smaller than the desired implant, so I go to 4.5. Okay, I pick up my drill 4.5 by 10 millimeters. Let's check always if it's the right drill. Yeah. Okay. Let's see. And I go down up to the stopper. Take a look at this. Okay, for soft bone, my drilling sequence is now already finished. I used only 1 taper drill. Let's check. Next step, how would it be for normal bone? Okay, for normal bone, I use the 3.5 drill, and then I go as my second and last drill to the same diameter as the implant to be placed. Okay, the 3.5 and then the 5/0. These are my 2 taper drills for normal bone hardness. Okay. Check. Okay, it's done with the 3.0, and I connect my last drill, the 5/0. That's it. Drilling for normal bone hardness is done. Okay. Let's check what would be the protocol for hard bone. The guide drill I already used. Now I use the 3.5 taper drill, and then as my last I go 1 bigger than my desired implant. Okay, 3.5 I put here. Okay, let's start drilling. Okay. 3.5, and then I use the last one, 5.5. Let's see. Go down to the stopper. Okay, my drilling is finished. When you now compare, you can see also the difference in the diameter. Soft bone, final drill was 4.5. Normal bone hardness, diameter 5. And hard bone, diameter 5.5. Okay, I pick up my implant. So you can see it's an implant with mount. Okay, like this. As it is with mount, I pick here my mount driver. I change the speed and torque for my motor, and I'm ready to place the implant. So I go directly with the mount driver to the mount, up to the stopper, and then instead of wiggling, I start drilling very slowly, and the implant comes out very easily. Okay, so I use normal bone. I place and I start turning in my implant very slowly, maybe 25 rounds per minute, and I go to a torque maybe up to 30 or 40. Okay, that's enough torque. So you can see I place my implant, but not yet to final position. There's maybe 3 millimeters still outside of the bone. Okay. Now I remove the mount. I use screwdriver. When I have low implant stability, I can secure my implant with this tool. But normally when I reach a stability of 30, it's maybe even not needed. Okay, I attach and I can remove the mount. Show you. Okay, and I can pick up, take away. Okay, now I would like to place my implant in final position. What I normally do, I take the implant, the fixture driver, and I use the torque wrench. Why I use the torque wrench? I still can manipulate easily in different directions. I can do small correction of my angulation, and I have a good feeling. I can also measure the stability, the primary stability with my torque wrench. You can see I'm here now maybe at 20 Newton centimeters, and as it is a conical implant, torque should go up. Now I'm maybe at 30 Newton centimeters, but the implant is still not in final position. So I screw in. Okay. Now I'm on bone level. I can check. Yeah, I'm maybe at 35 now. It starts turning just at 35. Okay, maybe a little bit more. Yeah, I'm almost 40. So with this protocol, I'm very secure. I can divide in between different bone hardness, and to be sure you have the right primary stability. How do I know which bone hardness I will have? Well, it is kind of experience. When you drill, you feel it. You can also know it by localization. By example, lower anterior is often hard bone and upper posterior is often soft bone. When you do a coni bean, then often implant bone quality is marked like this. So I have here, in this case, it was a case from today, I have bone quality of medium. Okay, let's check with the ISQ measurement. It's very easy to use. You have this multi-pack, it's magnetic, connected to the driver. You screw it in on the implant, just by hand torque, maybe 5-8 Newton centimeters. Then you use your tool and you hold it in about a 45-degree angle. And it's showing me a quotient of 78, which is very nice. It's exactly what I wanted. Now I can remove the multi-pack and I can decide if I would like to go closed healing or open healing. As I have normal bone, I have a good primary stability, let's say easy case, I place an open healing cap. It's the healing abutment and an open healing, like this. I can say the Hiossen ISQ3 is very easy to use. I had no problems, just one misunderstanding in the beginning. I placed an implant and I had a quite high torque. When I did the reopening, I measured 28. So it was very low. I was really disappointed because surgery was easy and I expected a really high torque. But then I realized you can read this number in two different ways. So my bad implant stability was in fact very good. Okay. Dear colleagues, thank you very much for your kind attention. I hope you liked this short presentation. If you have any question, please feel free to contact me. Thank you very much. Bye.